Welcome to the Deep Dive. We're the place where we take your sources, dig into them, and pull out the key insights. Saves you time, gives you understanding.
And today we're diving into some really interesting material you sent over. It's all about data modeling and specifically this idea of entities.
Yeah, entities. And look, whether you're, super technical or maybe just curious about how all this digital stuff gets organized, well, we want to make it clear.
Exactly. Hopefully give you a few of those aha moments without getting totally lost in jargon.
Right. So our mission today,
Mm-hmm.
get a handle on the basics of data modeling, especially that really critical first step, defining entities.
Mm-hmm.
Why is it so crucial when you're building systems?
And the sources use some great analogies we'll get into, like building construction, jigsaw puzzles. Really helps visualize it.
Okay, let's dive in. So the sources kick off with these comparisons,
Mm-hmm.
like building a house.
Yeah, think about it. You've got, I don't know, tons of steel, concrete, wires, glass, just piles of stuff.
Mm-hmm.
Imagine trying to put it all together without a plan. The number of ways you could mess it up is, well, practically infinite.
Right. Total chaos. And that's like raw data in a system project.
Pretty much. If you don't have a structure, a plan from the start, yeah, it gets messy fast.
And the puzzle analogy.
Well, a little kid's puzzle, maybe you can just try pieces randomly. But a 1,000-piece puzzle, forget trial and error.
You'd be there forever.
Exactly. For complex systems, just jumping in randomly, it's futile. You need a strategy.
So back to the building.
Mm-hmm.
You wouldn't worry about like the color of the door handles before the walls are even framed, right?
But that would be absurd. You need the main structure first, the framework. And in data modeling, that framework starts with the entities. Get those right first.
Then the details, the attributes come later. Just like with the puzzle, you find the edge pieces, the obvious sections, build the frame.
Uh-huh. Then you fill in the rest. It's about bringing order, creating that structure to work within, not just grabbing random blue sky pieces.
Okay, so structure is key.
Yeah.
Now, the sources talk about modeling happening in like two main stages.
Yeah, they break it down. There's basic conceptual modeling. They call it framework construction. Think of it as getting the main skeleton up.
Okay, the big pieces.
And then there's detailed conceptual modeling, more like the plumbing and electrical work, filling in the details within that initial framework.
And that first stage, the framework, is really the most critical.
Absolutely critical. The sources really stress this. Once that basic structure, those core entities and relationships are set, changing them later, it's incredibly hard.
Like trying to move the foundation of a house after it's built.
Exactly that. If the core definitions, the entities, are wrong, everything you build on top of that is inherently unstable. It compromises the whole system.
Makes total sense. Flawed foundation, shaky building.
Yeah.
So how does this modeling, this planning phase, actually connect to, the database itself?
The model is the blueprint. Simple as that. Once you've done the modeling, define your entities, their relationships, you have a clear plan for how to actually construct the database.
Plan first, then build the database based on the plan.
Yes. And here's a really important point the sources make. Data modeling defines the business. The source uses the term hono-an, defining the work, the business logic.
Ah, okay, so it's not about defining a specific database technology.
Not at the logical modeling stage, no. That same core understanding of the business, the entities, how they connect that same model, could be implemented on a relational database or a hierarchical one or something else entirely. The model captures the business essence.
That's a key distinction.
Yeah.
Business logic first, tech implementation second.
Yeah.
And the sources mention what comes after modeling.
Right. The next step is database design. It's where you figure out the specifics, how to map that logical model onto, say, a relational database.
Yeah.
You worry about things like data integrity, relationships between tables, indexing for performance.
The more technical stuff.
Yeah, vital for a working database, absolutely. But the source is clear. That's a separate step from the initial logical modeling we're focused on today.
Got it. So we're zeroing in on getting that solid architectural plan, the model right first. Where does this fit in the grand scheme of building software?
Well, the typical software lifecycle has phases, right? Strategy, analysis, design, development, testing, deployment, all that.
Mm-hmm.
Data modeling sits squarely in those early stages. Strategy and analysis. It's fundamental to understanding the business you're trying to build a system for.
Strategy and analysis.
Mm-hmm.
So it's really about understanding the business from the ground up, even if you know nothing about it beforehand.
That's the idea. It's about dissecting what the business does, what information it needs to manage, how things connect, asking those foundational questions.
Now, I bet a lot of people listening Especially business folks might think, yeah, but our business is super complicated. You can't just model it easily.
Huh? Yeah, that's a common reaction. The sources tackle that head on. They emphasize that data modeling isn't just about the final diagram or schema.
It's the process itself.
Exactly. It's the process of investigation, of discovery, of forcing clear decisions. It's like being a good detective.
A detective. How so?
Well, a detective doesn't start knowing the answer. They start by figuring out who they need to understand, what questions unlock the truth, how the clues fit. A good modeling process gives you that framework. It lets you tackle complexity systematically, drive decisions, even in an unfamiliar area.
I like that the data modeler as a business detective. And this leads to another interesting concept, suction power.
Right, a boost absorption skill. It sounds a bit mystical, but it's really about something crucial. The ability to effectively pull in the knowledge from the people who actually do the work.
The business expert.
The subject matter experts, yeah, they have the deep practical understanding. The modeler needs to be skilled at drawing that knowledge out, listening, probing, synthesizing.
The source uses martial arts analogies,
Hmm.
like judo.
Yeah, like absorbing an opponent's energy or using their force. The point is, IT folks can't be experts in every business. Banking, manufacturing, healthcare, they're all different.
So you have to leverage the expertise that's already there.
Precisely. The key is to skillfully extract and structure the knowledge held by the business users. You facilitate that knowledge transfer.
It's not about the IT team knowing everything, but being great at asking and listening. And then there's the orchestra conductor analogy.
Another good one. The conductor doesn't play every instrument, right?
No, definitely not.
But they guide everyone, bring all the different parts together, harmonize them to create the overall piece of music.
So the data modeler guides the understanding of the business.
Guides it, harmonizes the different viewpoints, leads the process that results in those key decisions about how information is structured, fosters that shared understanding.
The source even mentions going into a semiconductor company with, like, zero prior knowledge.
Yeah, and the point was, even without that specific domain expertise beforehand, the modeling process itself worked. That suction power, that structured way of questioning and discovery, that's where the power lies.
The method unlocks the knowledge.
Yeah.
Okay, now shifting gears slightly, the move from modeling to design, and something about project plans being misleading.
Yes. The source makes a strong point here. Once the modeling is truly done, meaning all the big human decisions about entities, relationships, core attributes are made and agreed upon.
The fundamental business logic is set.
Right. Then the design phase translating that model into database specifics should be mostly rule-based. It shouldn't involve a ton of new high-level business decisions.
It's more technical translation at that point.
It should be. So the source gets a bit critical of project plans that show this massive chunk of time labeled design after the modeling phase is supposedly finished.
Why is that a red flag?
It suggests that maybe the modeling wasn't actually finished. If you still need tons of time for design, it often means fundamental business questions weren't fully resolved during modeling. It signals a potential misunderstanding of what true modeling achieves.
That's interesting. A long design phase might mean incomplete modeling. So let's nail it down. How does the source formally define data modeling?
It's defined as accurately identifying and creatively generating the useful business information that needs to be managed.
Okay, identifying and generating useful info.
And representing that information through relationships, making sure all the critical human decisions are baked right into the model itself.
So it's decision-making made explicit and structured, not just pretty pictures.
Definitely not. And the model needs to be concrete, detailed. It has to consider usability, how it connects to other things, flexibility for the future, growth, simplicity. It's got to be robust.
And the design phase is just
Yeah.
turning that model into database code.
Essentially, yeah. Transforming the decided model into the actual database structure, tables, constraints, data types. If the modeling was solid, a lot of that database build can even be automated with code generators.
Making the whole process smoother, hopefully less error-prone. Now, the source talks about two main tracks running in parallel during development.
Right. You've got information requirement design, that's our data modeling. And you've got user application requirement gathering, often called functional modeling. What does the user need the system to do?
The data versus the functions.
Mm.
And managing how these two tracks work together is key.
Absolutely crucial. The source outlines 3 common ways companies try to combine them.
Okay, what's the first one?
Functional modeling first. This is pretty common. You start with things like data flow diagrams, identify processes and where data is stored, data stores, and then you use that as input for data modeling.
Sounds logical, maybe.
Mm.
Start with the workflow. What are the upsides?
Well, people feel it aligns with how they think about processes. DFDs are familiar tools for many analysts, and maybe it feels easier to start with what happens when you're new to a business area.
But there's a downside. The source argues against this.
Strongly. The big problem is it makes the data model dependent on the functions. So when the functions change, and they always do, you might have to change your data model.
Can you give an example?
The source uses payroll and employee data. Think about it. The core info about an employee name, address, position, that's pretty stable. But payroll rules, tax rates, deductions, they change all the time, right?
Yeah, regulations change, company policies.
Exactly. If your employee data model is tied directly to the current payroll functions, you'll be constantly tweaking the core data structure. It should be the other way around. The core data is stable. Functions adapt.
Okay, that makes the weakness clear.
And
Other risks.
big risk of creating inconsistent data silos. The HR system models employees one way for HR functions. The payroll system models them slightly differently for payroll functions. Suddenly you have two versions of employee. They don't match up. Reporting is a nightmare.
Yikes. Okay, so function first can lead to unstable, fragmented data. What's approach number 2?
Parallel Sue, doing both at the same time. Often happens on big projects, multiple teams, tight deadlines. Functional teams do their thing. Data team does theirs concurrently.
Sounds efficient, maybe. Get it done faster.
In theory. But the huge risk is lack of coordination. If you don't have really experienced people overseeing it, people who understand how data and functions must connect.
It's like building different parts of a car without checking if they'll fit together.
Exactly. Different teams build their pieces in isolation. Then, late in the project, the source says around 70% completion, you try to integrate everything, and surprise, things don't line up. Major rework needed.
Painful. The source calls pain a vital sensor.
Yeah, meaning if you don't feel the pain early, the pain of figuring out those integration issues because there's no holistic view, you'll feel much worse pain later when it's harder and costlier to fix.
So parallel work needs expert coordination, otherwise big risks later. Which leaves the third option, data modeling first. This is the preferred way.
Presented as the direct route, yes. The argument is that data modeling is inherently more objective and concrete. It forces you to define things precisely.
How so? Compared to functional modeling.
Well, DFDs can be a bit abstract, showing flows. Data modeling demands you define the sets. What is an employer? Full-time, part-time, contractor? Define it. What is a spouse? Legal definition. Common law. The source jokes, could it even be a pet in some weird context?
Okay, it forces absolute clarity on the nouns, the things.
Exactly. What belongs in the set, what doesn't. Concrete definitions. Now, the challenge is doing this well, especially without deep business knowledge initially, takes real skill that, again.
It requires expertise to define things objectively without being the business expert yourself.
Right. But the payoff is huge. The data model becomes stable. Functions can change, evolve. They're like seasoning on the core data structure, but the foundation remains solid.
And it prevents those data silos we talked about. Everyone works from the same core data definition.
Precisely. A much more robust, future-proof way to go.
Okay, that makes a compelling case for data first. Now, the source also mentions logical versus physical modeling, briefly.
Yeah, just a quick distinction. Logical modeling is about the what. The business information structure, entities, relationships, independent of any specific database tech or performance stuff.
The pure business view.
Exactly. Physical modeling is the how. How do we actually implement this in Oracle or SQL Server or whatever? How do we optimize it for performance? How is data distributed? That comes later.
But we've been focused squarely on the logical part today.
Yep. The source warns against mixing them too early. Don't start worrying about database performance tricks when you're still trying to define the core business entities logically. It muddies the water.
Keep the business logic clean first.
Got it. So what are the absolute fundamental pieces of a data model? The building blocks.
3 core things.
Yeah.
Entities, the things we manage. Relationships, how those things connect. And attributes, the characteristics of those things.
Entities, relationships, attributes, ERA. And we're spending most time on entities today.
Because they are the absolute foundation. And the source makes a key point. Entities are fundamentally sets. Set.
Sets. Like in math class.
Kind of. The critical thing is how you define the set. What are the rules for membership? What's in, what's out? That definition can totally change the model. Is it the set of students or the set of people? different sets, different models. How you group things matters immensely.
Defining the boundaries of the things we're managing, and getting that right is tricky.
It requires real judgment. You need objective criteria based on the business reality to define these sets effectively and accurately, not just gut feel.
Objective criteria, like a standard test. Yeah, like a litmus test, something that gives you a consistent answer about whether something belongs in the entity set or not, regardless of who's asking. That consistency builds the reliable foundation.
So it's rigorous definition, clear boundaries. And modeling isn't just a technical task. It's about
Communication, fundamentally. It's a dialogue between the modeling experts and the business experts. The goal is blending that technical skill with that deep business knowledge.
bridging the gap.
Exactly.
Yeah.
How does the modeler understand the business? They could try to become an expert themselves, often impossible. Or, much better, they establish really good communication with the business users.
A shared language, shared understanding.
Right. The source even mentions training business users on basic modeling concepts, maybe even giving them little tests so they can give better input, get them drawing ERDs.
Wow, getting business users to draw diagrams. That's real buy-in.
Right.
Now, how do you actually get that crucial info out of the business users? Seeing is believing.
Yeah. The idea is sometimes people can't articulate abstract needs well, but if you show them something concrete, a draft model, some options, it prompts them.
Like in a shop, easier to say, I want that one, when you see the options.
Exactly. You present information in a way that makes them think concretely, reveal their understanding, or their misunderstandings, like an investigator guides a witness.
Prompting them to surface their real thoughts.
Yes, and it can act like a sort of lie detector, too. If you ask careful questions based on a proposed model, inconsistencies in their answers can reveal flawed logic or hidden assumptions you need to address. It takes logical thinking, experience.
Digging deeper than just what they say initially. Okay, let's circle back to the absolute core, defining entities.
It really is step one. Define them from the highest level first. What is the core subject of what we're trying to manage here? The main focus of the system. Right. And that subject shapes the entities. Modeling a corner store. Your person entity is simple. Modeling a huge government agency. Person becomes much more complex, different roles, statuses, relationships.
Context is everything.
Which leads to a point about generic ERP software. They often define entities based on what most companies need, but that might not be the right definition for your specific company. It's like off the rack versus a tailored suit.
The tailored model fits your specific business better. Okay, so what makes a good entity? Some initial characteristics.
Okay, first, it should be something persistent, tracked over time, not just temporary. Second, it needs clear, objective membership rules, who or what belongs in this set. Remember, pay trash the dog. Is he a cart dog entity? Yeah. Needs clear rules.
Clear boundaries.
Third, an entity has instances, rows, and attributes, columns. It defines an area of information. A single attribute isn't an entity. Fourth, its attributes should be about the entity itself. Fifth, it must have attributes. And finally, good places to look for candidates are existing master files, other data files, maybe data stores from DFDs.
Persistent, clearly defined, has characteristics. But finding them isn't always obvious.
Oh, definitely not. Lots of ambiguity. Is an employee different from a contractor? Or are they types of personnel? Raw material versus finished goods, separate entities, or just a status change? Sales region, delivery zone, same thing or different. Combine, split, keep separate. These are the judgment calls.
Nuanced decisions based on the specific business. And the source gives more examples of common confusion.
Yeah, the employee one again. What about retirees? Are they employees? A separate retiree entity or part of personnel? How do executives fit? And the customer-vendor tangle. What about a company like Samsung that's both? Or a bank that's also a customer?
Real-world complexity messes with neat boxes.
It does. And things like payer versus bill recipient. Are they entities or just roles a customer plays? The source points out, sadly, that many designers lack deep clarity on this, like that database table called customer that was actually storing contracts.
Ouch. Getting the fundamental thing wrong from the start. So how do we actually start identifying them? Where do the candidates come from?
The idea is, first, just gather candidates. Don't judge too harshly yet, like auditioning actors before casting. Use that horizontal thinking, even without deep knowledge. Look for the key nouns, the main concepts.
Brainstorm the potential things. Where do we look?
Existing stuff is gold. Business documents, forms, reports, manuals. Talk to users. What words do they use for key things? Look at existing system docs, even if they're old and imperfect.
Even flawed documents can help.
Absolutely. They contain the vocabulary, the clues. Maybe not the right structure, but the words are there. The source mentions just gathering all related docs, unfiltered. A good modeler can sift through, spot patterns, inconsistencies, and form smart questions.
Use the old stuff as breadcrumbs.
Exactly. It's iterative. You show things, you ask questions, maybe you even facilitate debates between users with different views to uncover the real truth. The goal right now is just to get a list of candidates. The heavy filtering comes next.
Gather first, refine later. Okay, great. So, wrapping up this part of our deep dive.
The big takeaway really is defining entities clearly, accurately, with shared understanding is job number one. It's the absolute foundation of data modeling. Get the core things right.
It's laying that solid foundation for the building, getting those essential puzzle pieces locked in first.
And the next logical step, which the sources get into, is how you actually evaluate those candidate entities using specific objective criteria. Something for another deep dive, perhaps?
Sounds good. And finally, a thought for you, our listener, to take away. Think about the data in your own world, your job, your life. How clearly are the things being managed actually defined? Could you apply some of these ideas about entities? Are there ambiguities lurking? Ponder the entities in your context. Thanks for joining us on the Deep Dive.